Hello children, welcome to channel Sube. Children, today I am going to discuss question number 24 from the MCQ part of 2022-23 Physics New Syllabus paper. A ball is projected at a velocity of 10 ms power minus 1 horizontally from the top edge of a building of height 20 meter. While falling, the ball splits into two identical pieces x and y. Then pieces x and y hit the ground simultaneously at horizontal distances 10 meter and capital R respectively from the building as shown in the figure. Neglect air resistance. What is the distance capital R? First one 20 meter, second one 30 meter, third one 40 meter, fourth one 50 meter, fifth one 60 meter. So children, there are two methods to solve this problem. One is using the conservation of linear momentum theorem. So let us try this first object. First one, that means the x1, the object x. So let us suppose the time taken for this one t. So we have to find out it first. So let us solve downwards. The topic is downwards. So the initial velocity is 0 downwards because it has only horizontal velocity 10 ms minus is given. So the distance s is 20 meters. So the acceleration downwards is gravitational acceleration, so that is 10 ms power minus 2. So what we need is t, the time. So we can use s equals ut plus half at squared equation. So s is 20 meter. So u is 0. Since u is 0, this term totally goes to 0. So therefore we don't have to write it. So half times 10 times t squared, then 0 cancel, then 2 times 2 4, square root of 4 is 2, so the time is 2 seconds. So that is the time for the first object capital X. So now let us try to find the initial horizontal velocity of this piece after splitting. So I place it here. They have given as 10 for the initial object before splitting, but we can't use that one for this half. So let us suppose the initial velocity as soon as it got splitted x, so the simple x. So let us calculate to this direction horizontally. The topic is horizontal, so we can use only s equals ut equation because there is no acceleration to this way. Acceleration is 0. Or either you can use s equals ut plus half a t squared equation, but here you have to substitute a as 0. Then automatically this equation converts into s equals ut because this term goes to 0. So that way also you can use, but that way also you come to this equation, therefore you have to use this one directly. So s is 10 they have given. So u this said u is x, we have taken it as like that. So time is the same time we have calculated here because the same time simultaneously it moves downwards and horizontally. So x equals 10 divided by 2 is 5 ms power minus 1. So that is the initial velocity of this piece x after splitting. That is the pieces x and y, yeah, they say pieces, so we also say pieces. So the initial velocity of piece x is 5 ms power minus 1. So now let us go to the conservation of linear momentum theorem. So the initially the ball was like this. The velocity was 10, mass m. So what happened? While falling, the ball splits into two identical pieces. So therefore we can draw it like this: one piece and the other piece. So this one is x, this one is y. So we have already found that velocity of x is this one, 5. 5. So we calculated the initial velocity as 5 because they have given these two data. So to have a displacement this way, it must have some initial velocity, not this one, because if you use this one you don't get this value. So therefore the initial velocity for this particular piece can be calculated by using these two data, because it is identical for this object x only. So therefore we calculated it like this, so we can use it here. So this one, now suppose y, the velocity, initial velocity. So that for that also we can't use this 10, because after that it is splitted. So let us use this conservation of linear momentum theorem. So what we have to do to get the multiplication of m times velocity? So the initially m times 10 then equals, these are the masses m divided by 2 and also m divided by 2. So 5 times m divided by 2 plus, because same direction, y times m divided by 2. So m cancel, then 10 equals 5 divided by 2 is 2.5 plus 5 divided by 2. Then minus 10 minus 2.5 is 7.5. Then times 2 equals y. Then y equals 15 meter per second. So that is the velocity of x, velocity of y. So now let us calculate the distance, horizontal displacement of y. So like this, x here. So here the piece x, here the piece y. So now we are going to calculate for this the object y, the piece y. So the time is same. So the time is same, because this distance is same, is still it is not changed, 20 meter. So this for this second half we are doing. So the velocity we know 15 meter only for half piece, this half piece. (15 meter per second). So we can find out now this R, that is what they want us to find out. So still the time is 2 seconds, because this 20 meter is still not changed. 20 meter is the same. So we don't have to calculate this way, because even though we calculated, we get time as 2 seconds, because initial velocity 0, acceleration 10, then distance s, displacement 20 downwards. So time s equals ut plus half at squared downwards. So 20 equals 0 plus half 10 times t squared. So we get 2. Then we calculate this way. S equals ut only, you can use like this. So S is R now. This is what we are going to find out. So the velocity we know, velocity we know 15 times 2, the time is here 2, then 30 meter. So that is the answer. This one is what they want us to find out. So that is what we have found now, this distance to this y object piece. So the answer is this one, second one. This is not a big difficult question, so let us check the answers. 24, 20, 21, 22, 23, second one, correct. Now children, I am going to show you the other method using the center of gravity of the system after getting splitted. So let us copy the question here. So the center of gravity of this two, before that I will show you how to find what is the center of gravity, the idea. So if I asked what is where the center of gravity of this ball, you no problem, you will mark here at the center as the center of gravity, so that you can do, you will show surely the center of gravity is here. But if I asked like this, after getting splitted, what is the where is the center of gravity? If I asked to find out, to mark the center of gravity, to show the center of gravity of this system, means this, of these two pieces, totally of these two, where is the center of gravity? So you might get problems. Some people might mark here, some people might mark here. So actually definitely you will not be able to mark it sometimes. So how to find out it? So assume that these two are connected like this by a small stick which has no mass. So somehow connected using a small stick which has no mass. So now these two are connected like this. So the masses of these pieces are same. Masses are same, m divided by 2, m divided by 2. The forces acting downwards is also same, mg divided by 2, mg divided by 2. So since these forces are same, where is the point, where is the balancing point? If we try to balance it using a pivot or your fingertip, you can keep this, you can place this on your fingertip somewhere at which you can balance it. If you placed your fingertip here, definitely you can't balance it because this side is heavier. Not heavier, the same mass, same force, same weight, but the momentum is greater. Therefore, it turns like this and fall down. So, if you put your fingertip at center of this equal distances from the both objects, both pieces, at the center, at the midpoint, what will happen? Definitely you will be able to balance it. You will be able to balance this stable. That is the stable balancing point. So that is what we call center of gravity, G. So since these masses are equal, the forces are equal, therefore the momentums are equal when we placed the pivot at center at the midpoint like this. Then easily like that we can decide the center of gravity is this place. It is at this place. So the center of gravity doesn't change. So I use another color, red color for this. Center of gravity is here at the center, at the midpoint. So let us calculate for the center of gravity. Center of gravity. So center of gravity of this system after splitting, after getting splitted, the center of gravity moves like this along this path. Center of gravity moves like this. So this is the path for the center of gravity. So let us find out this distance r dash, say, that we can find out using this one, but they have given, because this one can be used for this ball. That ball, even though it what happened while falling, the ball splits into two identical pieces, but the center of gravity is moving as if it were not got splitted, as if it were not gotten splitted. So as if still the ball total is moving, as if the ball total is moving. So now let us calculate for this capital R dash. So the time still is t equals 2 seconds. It doesn't change because this distance is the same. So therefore time is 2. We don't have to calculate again this way. It is, we have done already. So let us calculate for this way. Only we can use S equals u times t. S is r dash now. So we are calculating for the center of gravity. For the center of gravity. For the center of gravity we are calculating. So r dash equals, this value now you can use 10 times t is 2. So 20 meter r dash. So here 20 meter. This distance is this one, this one. Now r dash is 20 meter. So this one 10, this one 20. So what is the value of this one? Then 10, 10, 10, 20. So since this center of gravity is at the center of these two pieces, then this side also 10. So what we have to find out is this total distance towards y from the building. So 10, 10, 10, 30, 10, 10, 10, 30. So easy. This one is the answer. Second one. Since these objects had the same mass, it was easier. And also there is another method, but it is a little bit difficult to find out the value for capital R, what they ask. So this is the building, this is the ground. So the first piece of this ball X falls here, 10 meter away. So the mass of that is m divided by 2. The force is mg divided by 2. The center of gravity is here. Center of gravity falls here. Yeah, that is the full ball. The force is, if it is full ball, m. The center of gravity owns to the full ball. This two pieces, both two pieces altogether, the mass is m. So we have found it 20 here, 20 meter. So this distance is 20 meter. Then the other half, this half y fell somewhere, the distance is r. That is what we have to find out. So the mass is m by 2, but force is mg divided by 2. So let us take the momentum of center of gravity. Center of gravity is this one, red color one, mg here, force, we want force. So mg times the distance, force times distance, then 20. We write 20 mg. So that is towards clockwise. So that is the equation 1. Then this one, object, the piece A, not a x, xy, they have given xy. So for x, what is it? Momentum of x, that is force time the distance, perpendicular distance, 10 times mg by 2. So that is the second one. Third one, momentum of object y, piece y, this one, force time distance, perpendicular distance, force is mg divided by 2, then r times mg by 2. Third one. So this center of gravity, the momentum given by the center of gravity must be equals to the other two pieces. So first one must be equal to the second one plus third one. So therefore we can write 20 mg equals 10 times mg divided by 2 plus this one r times mg divided by 2. So mg cancel, then 20 equals 10 divided by 2 is 5 plus r divided by 2. Then 20 minus 5 is 15 times 2 is r. Then r equals 30 meter. So the same answer. This one, same answer. So you don't have to do the both. You have to do one of these methods. One of these methods. This one no. This one no. This one is rather difficult, longer. This method is easier. So children, I think you can understand this. So let us do some target questions. So I showed you both methods now. Both methods. In the second method, there are also another method. There are also two methods. In the second one, means center of gravity method. So let us go to the target question now. So children, we have used now up to now 20 minutes. So we are not going to do the target question here as a separate video. I will do it and upload to the YouTube, so you can see that. You can watch it after watching this one. So I think you are happy, children, because I discussed the original question like this, and I showed you all the two methods, and also I explained like this the center of gravity method, and also there are two separate methods at the final calculation. So children, I think you are happy. So if you are happy, please make me happy too by subscribing my channel if you haven't still done it. Then share my link among your friends, and also press the bell icon. So press the thumb up icon to give me a like, because then only my video will push forward by the YouTube. Otherwise it will be thrown to a corner. So children, help me to improve my channel. Then see you tomorrow at 6 o'clock in the evening. Goodbye children.